hovering beside 3I Atlas, Hubble detected a pale, ghost-like signature, so faint it almost blended into the darkness of space.
What do you call something that appears beside an interstellar comet, yet behaves as if it doesn't belong to nature at all? When Hubble turned its eye toward 3I Atlas, astronomers expected dust, ice, and silence. Instead, it captured a pale, ghost-like object drifting right beside it, moving with a calm, unnatural steadiness. First it looked like a blur, then it became a shape, and suddenly the question no one wanted to ask became impossible to avoid. What exactly is traveling with this comet? The moment the mystery first appeared. When the new Hubble frames arrived, the team expected nothing more than another faint look at 3I Atlas drifting through the dark. Interstellar comets usually appear as messy shapes, wrapped in strange dust patterns that shift every time sunlight hits them. But this time, the raw images carried something unsettling. Just beside the comet, tucked into the blackness like a blemish on the void, sat a pale, rounded mass. It didn't look sharp or bright, but it carried a presence that pulled attention immediately. A strange white form, neither part of the tail nor the core, holding its position with surprising steadiness. It wasn't the brightness that made people pause. It was the stillness. Dust clouds flicker and stretch. Ice fragments scatter. Gas fades. But this object simply stayed there, floating beside 3I Atlas as though it belonged to it. At first, scientists tried to fold it into old theories. They leaned on the idea that 3I Atlas was surrounded by a cocoon of dust, the same one described in earlier observations. A soft halo, shaped like a teardrop, is drifting away from the nucleus. Maybe the ghost-like patch was just the thickest part of that cocoon. Maybe the angle made it appear more solid than it truly was. That was the easy answer. But the more they examined the frames, the more the object refused to blend in. It kept its form through multiple images. It didn't blur or stretch. It didn't respond the way loose dust normally does. Instead, it hovered beside the comet in a way that felt too intentional, too consistent, almost as if it were following the comet's slow rhythm. The white blob returns in a new form. As analysts dug deeper into the new Hubble images, an old headline resurfaced, a piece from only a few weeks earlier. It mentioned something odd captured by ground telescopes, a smooth white blob drifting near 3I Atlas. At the time, the scientific community brushed it off as a common artifact. Telescope halos, camera noise, atmospheric distortion. There were a dozen safe explanations. But now, with the same soft, pale object appearing beside the comet in crisp Hubble clarity, that old dismissal didn't feel so safe anymore. Ground telescopes struggle with the atmosphere. Their images often look smeared or distorted, which makes unusual shapes easy to ignore. But Hubble doesn't have that problem. It sits above the distortion. It sees the sky for what it truly is. And yet, here it was, showing the same white mass, holding shape, holding position, and slipping through the dark as if tethered to the comet's side. It drifted with the comet like a quiet shadow. It didn't fade as the angle changed. It didn't scatter when the dust thinned. It looked less like a cloud and more like an object with enough structure to keep itself from dissolving in space. That was the moment researchers realized something. The ground-based sighting wasn't a mistake, it was a preview. The more they cross-checked old frames, the more the mystery deepened. The shape was nearly identical to what Hubble had just revealed. That consistency meant one thing. Whatever this ghost-colored mass was, it had been there from the beginning, watching, traveling, keeping pace with 3I Atlas from distances too great for coincidence. When the cocoon theory began to break, for months, researchers relied on one explanation to calm the growing questions around 3I Atlas: the cocoon theory. According to early observations, the comet carried a large teardrop-shaped cocoon of dust that wrapped around its icy core. That idea made sense at first. Interstellar comets often behave strangely. Their dust can drift in ways that don't match what we see in local comets. A cocoon was a simple, elegant way to explain the odd glow and blurred edges. But once Hubble sharpened the view, that comfortable theory started to crack. Dust clouds don't behave like walls. They don't create a clear, round patch that sits neatly off to one side. They don't maintain shape against solar wind or rotation. Yet the so-called cocoon wasn't spreading evenly around the comet. It wasn't soft. It wasn't fading. Instead, one part of it, the ghost object, stayed firm and uniform, almost as though it had its own structure hidden inside. The shape didn't drift the way the rest of the dust did. It didn't dissolve as sunlight hit it. It didn't sag into the comet's tail. Instead, it held its position like a steady companion, tucked into the dust like a passenger wrapped in a blanket. The early images may not have shown a teardrop-shaped shell at all. They may have been showing the dust reacting to a second object. The more analysts compared the early ground images with the new Hubble frames, the clearer the problem became. The cocoon wasn't shaping the object. The object might have been shaping the cocoon. Dust tends to cling to solid surfaces, piling up around edges, drifting along contour. If something solid sat near 3I Atlas, dust would naturally gather and wrap around it, creating a shape that fooled everyone into thinking the comet carried a single, elongated glow, a movement pattern no one expected. The turning point in the investigation didn't come from brightness or shape. It came from something far more revealing: motion. When analysts stacked the Hubble frames into a smooth time sequence, the ghost object began to show a rhythm of its own. Not a chaotic drift, not a scatter of random particles, but a controlled, almost steady pattern that held close to 3I Atlas, like a quiet partner. Natural debris doesn't behave that way. Dust escapes, ice fragments wander, gas spreads, but this pale mass kept a near constant spacing, almost like it understood the comet's movement and adjusted accordingly. It didn't cling tightly, but it didn't drift away either. It simply paced the comet, matching its slow roll as though the two were somehow linked. The longer the team studied the sequence, the more unsettling the pattern became. Every tiny rotation of the comet seemed to produce a subtle answer from the ghost object. When the comet leaned, the object compensated. When the tail direction shifted, the object drifted slightly to maintain its offset. The motion wasn't perfect, but it was far too organized to be dismissed as drifting dust. Some described it as shadow movement, where two objects drift together without actually touching. Others compared it to the way small satellites around asteroids fall into gentle, unpredictable orbits. But even those comparisons felt weak. Those motions are messy. They wobble, speed up, slow down. This one was calm, steady, almost patient. The most interesting detail wasn't what the object was doing. It was what it wasn't doing. It wasn't being pushed away. It wasn't dispersing. It wasn't losing its shape. The light breeze of space should have scattered it long ago if it were nothing more than dust. Its stability was the clue no one wanted to acknowledge. Something about this object allowed it to stay beside 3I Atlas, not behind it, not in front of it, but right beside it, as though it were following a path carved out just for the two of them. The comet was no longer the only traveler in the story. It had a companion, one no one could yet explain. When the light began to reveal the truth. As 3I Atlas moved deeper into a clearer region of space, sunlight struck the comet from a new angle. This was a quiet but critical moment, because changing light often exposes things the darkness hides. When the new illumination reached the ghost object, something unexpected happened. The edges sharpened, not into a perfect outline, but enough to show that the object wasn't dissolving into space the way dust normally does. Instead, its boundary held steady, giving the impression of something with weight or structure beneath the haze. There's a point where speculation shifts into real curiosity, and this was that moment. The more light touched the object, the more it resisted the behaviors scientists expected. Dust brightens unevenly, gas glows briefly, debris flickers, but this object responded in a way that felt deliberate. It brightened smoothly, held its contour, and revealed a faint shading inside, suggesting there was more to it than an empty patch of dust. Even more striking was the way the surrounding dust behaved. Instead of spreading evenly, it seemed to cling around the white mass, like a thin layer caught on a hidden surface. This clinging pattern didn't match any natural scenario they modeled. It looked as if the dust wasn't creating the shape, it was draping over something already there. In other words, the dust wasn't the source, it was the disguise. The team mapped the brightness changes frame by frame. The readings didn't show the randomness of a loose cloud. They showed consistency, the kind of consistency that appears when light reflects off something stable. That stability didn't match dust, ice, or gas. It matched an object that wasn't breaking apart or drifting into the comet's tail, the strange stability that shouldn't exist. As the dust around 3I Atlas continued thinning, analysts began focusing on something even more puzzling than its shape or brightness: its stability. Space is not calm. Even small forces can push fragile material in unpredictable ways. A bit of solar wind, a tiny jet of gas from the comet, or a shift in direction can break apart even the thickest dust patches. Yet this object didn't react to any of it. It floated with a calmness that felt completely out of place. Researchers replayed the footage again and again. The dust around the comet flickered and swirled, but the ghost object remained steady, almost anchored. It didn't twist, it didn't deform, it didn't thin out. Instead, it held itself together like a silent passenger drifting beside the comet with quiet intention. Natural debris behaves like chaos. This behaved like something with identity, something with enough solidity to resist the constant tug and pull of space. Its boundary didn't flutter, its interior brightness didn't fluctuate. Even as the comet rolled and shifted, the ghost object maintained its presence, as if its stability was not a coincidence, but a feature. The strangest part came when they compared the stability over time. 6 hours, 12 hours, 24 hours. The object kept the same distance, the same soft outline, the same quiet brightness. It was as if the space around it was carved out specifically for it, a pocket where nothing disturbed its calm. Every model they ran failed. Dust didn't fit, ice didn't fit, gas didn't fit. Even the idea of a drifting fragment didn't match the consistency of the shape. Whatever this ghost object was, it behaved like it had a reason for being there, a role in the strange journey of 3I Atlas. Patterns hidden in the darkness. The deeper Hubble continued tracking 3I Atlas, the more the ghost object began revealing a quiet pattern, not in motion this time, but in how it reacted to darkness and light. In dim frames, the object almost seemed to soften, blending into the shadow. But whenever a clearer beam of sunlight hit the comet, the white mass brightened in a way that didn't match the fading dust around it. This contrast created a strange rhythm, almost like the object carried its own reflective behavior. Natural dust brightens sharply and then fades. It responds instantly to light because it's light, loose, and unstable. But the ghost object glowed with smooth transitions, as if its surface absorbed and released brightness at a slower, controlled pace. It didn't flash, it didn't sparkle, it responded as though it had a surface, something that could catch sunlight rather than scatter it. Then another pattern appeared. When the comet tilted, the ghost object's brightness shifted too, not randomly, but in a way that made it look like it had its own facing side, almost like the object wasn't just a floating chunk of dust, but a surface with a front and back, reacting differently depending on the angle. This created a striking contrast in the frames, swirling chaos on one side and a steady, softly glowing presence on the other. The more the analysts isolated the ghost object's brightness against the comet's tail, the clearer it became that whatever this thing was, it wasn't reacting as part of the comet. It was reacting as something beside it, something following its own rules. When the comet's behavior started to shift. As Hubble continued watching 3I Atlas, another odd twist unfolded. The comet itself began acting strangely, not in a dramatic, explosive way, but in subtle shifts that seasoned astronomers quickly noticed. The rotation slowed slightly. The dust release pattern changed direction. Even the tail showed faint inconsistencies, as if something near the comet was affecting its behavior in ways no one had predicted. This wasn't the first interstellar object to surprise scientists, but it was the first to display changes that lined up suspiciously well with the position of a nearby mass. Every time the ghost object brightened or shifted in the frames, small changes appeared in the comet's motion shortly afterward. None of these changes broke the laws of physics, but they didn't fit the normal models either. It looked like a faint influence, a quiet tug or nudge that didn't belong. The most interesting detail came from a frame sequence taken over several hours. As 3I Atlas moved through space, the ghost object shifted slightly outward, almost like it was adjusting itself. Right after that, the comet's tail thinned out and pointed in a new direction. Not dramatically, but enough to register. The timing matched too closely to ignore. The idea seemed outrageous, but the alignment in behavior kept forcing the question back into the room. Comets don't respond to dust clouds. They don't react to gas pockets floating beside them. But they can react to nearby mass, even very small mass, in subtle, almost invisible ways. It wouldn't take much to shift a comet's rotation slightly or bend its dust plume in a direction that defied old expectations. The comet wasn't moving strangely on its own. It was moving in the presence of something that had been beside it the entire time. The data that no longer matched the models. When observatories began running the numbers, a new problem emerged, one that cut straight through every simple explanation. The measurements from the comet no longer matched the predicted model. Small variations in brightness, tail angle, and dust flow didn't line up with the standard behavior of an interstellar comet. Even the expected path of 3I Atlas showed tiny deviations, the kind that shouldn't happen unless something else was nearby influencing its journey. This wasn't randomness. This was a pattern forming outside the predictions. When researchers overlaid the ghost object's position on these inconsistencies, an eerie alignment appeared. Every cluster of odd readings, slight dips in brightness, subtle shifts in rotation, tiny timing mismatches happened at moments when the ghost object either brightened or shifted relative to the comet. Individually, these were small deviations, but together they painted a picture that felt impossible to ignore. Documentaries often reach a point where the evidence becomes too loud to downplay, and this was one of those points. The standard comet models were failing not because the comet was strange, but because something beside it was changing the environment around it. That realization forced the team to compare their data to older interstellar objects like 2I Borisov and Oumuamua. Those objects behaved unpredictably too, but not like this. They didn't carry companion masses. They didn't drag ghost objects through space. They didn't reshape the dust around them as if moving with something hidden in the glow. And then there were the dust trails. A typical comet tail stretches smoothly behind it, carried by solar wind. But 3I Atlas formed a faint split near the location of the ghost object, as if something was interrupting the airflow around the comet, the same way a rock splits water as it floats down a river. The ghost object steps out of the background. As the final batch of images arrived, the mystery took its most dramatic turn yet. With the comet now in a region where the lighting was cleaner and the dust less chaotic, the ghost object began separating from the background in a way that felt unmistakable. It no longer blended into the haze. It no longer looked like a smear or a random patch of dust. Instead, it appeared as a distinct, pale form drifting beside 3I Atlas with quiet confidence, as if it had always been part of the journey. The frames didn't show a perfect outline. Nothing in space ever does, but they showed enough clarity to make its presence undeniable. The soft curve, the steady brightness, the consistent distance from the comet, all of it pointed towards something with its own identity. It behaved like a companion object, not a byproduct, not dust, not gas, not debris, something that followed the comet with discipline, almost like they were two parts of the same story. The last observations highlighted something even more unusual. The object wasn't trailing behind the comet or lingering ahead. It remained beside it, traveling in tandem, matching pace without drifting away. That position was the strangest part of all. Nature doesn't place two unrelated objects side by side in the vacuum, moving together across interstellar distances. Something either binds them or influences them, and whatever that influence was, it had lasted through every phase of the comet's journey. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.